Fundamentals of Statistics, Measures of Dispersion, Chapter 4. In this lecture, we are going to understand the measures of dispersion and other type of measure. Within the measure of dispersion, we're going to go over the range, the standard deviation, and the variance. Measures of dispersion describe how the data are spread out or scattered on each side of the central value. The measure of dispersions and the measure of central tendency, which were described before, are both needed to describe a collection of data. So these are known as analytical methods to describe data. Another term for the measure of dispersion is the measure of spread. We're going to cover three specific types of measure of dispersion, and these are the range, the standard deviation, and the variance. So let's start with the range. The range of a series of number is the difference between the largest and the smallest values of observation. So it is defined as the R, and R is equal to the higher observation, and the largest observation, which is x sub h, minus the smallest observation, which is x sub I. This is the simplest and easiest measure of dispersion to calculate. The way that you do it is when you have a set of data, you have to make sure that the data is ordered from the smallest to the largest, and you just pick the first value and the last value and subtract them. This measure of dispersion also provides knowledge of the total spread of the data and its simplicity. If you want to calculate the mean range, it's simple divided the range by 2. A second type of measure of dispersion is known as the variance. And the variance helps to understand the fluctuation of observations around the mean. Remember that the mean is the average and is part of a measure of central tendency. Now, because we have population, which is the total collection of data, and we have sample, which is just a portion of that population, we also have a population variance and a sample variance. So for population, we use sigma square, and it's equal to the sum of all the observations minus the mean to the square to the power of 2 divided by the population size. When we talk about sample variance, it is defined as S squared and is equal to the sum of the observations, the individual observations, minus the average of that sample to the power of 2 divided by the sample size minus 1. The standard deviation is the third measure of dispersion that we are going to cover in this lecture. And as well as the variance, you have population standard deviation and you have the sample standard deviation. The standard deviation is a numerical value in the units of the observed values that measure the spreading tendency of the data. This means that if you have a large standard deviation, what it shows is a greater variability of the data than if you have a small standard deviation. So for a population standard deviation, we use the symbol sigma, and it's equal to the square root of the sum of the observation minus the mean to the power of 2 divided by n. If you use the sample standard deviation, you use the symbol S, and instead of using population parameters, you're going to use sample statistics. Now, we know that we have different measures that we can use, but when to use one instead of the another one? If you have a small sample size, let's say less than 10 data set, this is when you should use the range. Okay, and one thing that you need to understand is that as the sample size increases, the accuracy of the range decreases. That's why you use the range when there is a small amount of data or the data is too scattered. If you have a sample size greater than 10, you should use the standard deviation. So the range is a very common measure of dispersion and is also used in one of the principal control charts that we're going to see later on. The primary advantages of the range are in providing a knowledge of the total spread of the data and in its simplicity. It is also important to use it when the amount of data is too small or too scattered to justify the calculation of a more precise measure of dispersion. Remember that the range is not a function of a measure of central tendency. So as the number of observations increases, the accuracy of the range decreases. And this is because it becomes easier for extremely high or low readings to occur. So if you have a sample size greater than 10, it's when you should use the standard deviation. And the standard deviation is used when you need a more precise measure, when you desire that. A smaller standard deviation means that you have better quality because your data is not that spread out. There are three other measures that are frequently used to analyze a collection of data, and these are skewness, courtesy, and coefficient of variation. The skewness is a lack of symmetry of the data and is given by A sub 3. If this value is equal to 0, the data are symmetrical. If it's greater than 0, meaning a positive value, the data are skewed to the right, which means that the long tail is skewed to the right. And we can see this here. You see that the mean will be located to the right where the long tail is, and the median will be to the left. Remember that the median and the mean are part of the measure of central tendency. If the value is negative or less than 0, means that the data are skewed to the left, which means that the long tail is to the left. And this will have the mean to the left side and the median to the right side. And this is when the value is equal to 0, which has the mean and the median located in the center or the same place. So the skewness is a number whose size tells us the extent of the departure from symmetry. Now, courtesies indicates the peak of the data, the peakness of the data, and is represented by A sub 4. So it is a dimensionless value that is used as a measure of the height of the peak in a distribution. Now, the leptochordic indicates the more peaked distribution, which is the first one. Then the platychordic indicates a more flatter distribution. The mesochordic is what we call a normal distribution. So between these two distributions is one referred to a mesochordic, and this is what we call the normal distribution. Then the last type of measure is the coefficient of variation. And this is a measure of how much variation exists in relation to the mean, which is a measure of central tendency. Now, another type of measure is the measures of association. And this has to do with the correlation coefficient. And this measures the strength of the linear relationship between two variables. And is represented by small r. If the value of the r is equal to 1, it means that it is perfect positive linear relationship between x and y. So it's always between two variables. If the value is equal to -1, indicates that it's a perfect negative linear relationship between x and y. And if the value is equal to 0, it means that the variables are uncorrelated. So let's go over this example. Suppose we have three groups of students who have obtained the following marks in a test. The arithmetic means of the three groups are also given below. So you have three groups, A, B, and C. You have the different test values, and you have the arithmetic means for each one, which is represented by X bar. So what is this data? What does this mean? You can see that in a group A and B, arithmetic means are equal to 50. Remember that the means are part of the central tendency measures. Now in group A, the observations are concentrated on the center because the values are closer to 50. So we say that there is a consistency or consistency in the observations in group A. Now in group B, the mean is 50, but the observations are not close to the center. And the closeness is given by the measures of dispersion, because it's how spread out the data tends to be based on a target value in the center. You see that you have 30, 40, 50, 60, 70. They're not as close as group A. So one observation is as small as 30 and the other observation is as large as 70. And this type of data will give us the range. So it means that there is a greater dispersion in group B. In group C, the mean is 60, but the spread of the observation with respect to the center 60 is the same as the spread of the observation in group B with respect to their own center, which is 50. And you can see that. So in group B and C, the means are different, but the dispersion is the same. So we're using two types of measurements. We're using the measures of central tendency and the measures of dispersion. In group A and C, the means are different and their dispersion is also different. The dispersion is an important feature of the observation and is measured with the help of the measures of dispersion, scatter, or variation. The word variability is also used for this idea of dispersion. So remember, the measure of dispersion tells you how spread out your data are to the central value, which is your average of your mean. So it shows the variation of your data as well. So let's work another example. this one we have to find the range, the variance, and the standard deviation of the following numbers. You got 8 numbers, and they vary from 1 to 10. So how do we do this? We can use Excel, we can use Minitab, we can do it by hand. So if we use Excel, just copy the numbers in a column, and then to find the range, there's no direct formula, but you can find the maximum number from this column minus the minimum number from this column, and that gives you the range. For the standard deviation, there is a formula for it. So it's STDEV, and you select the numbers and enter. So the standard deviation is 2.96. The variance also have a formula, so it's VAR, and you select the numbers. So you have a range of 9, you have a standard deviation of 2.96, and you have a variance of 8.79. So the standard deviation gives you the value of how your data are spread out, okay, with relationship to a center. And then the range give you, if this range is small, you can conclude that your data is also dispersed. If we use Minitab, just have to copy the numbers. I copy it in a column, so I go to data, column statistics, and I select the mean. For the input variable, I select my column where they are located, and I click OK. So we're looking for the standard deviation. Standard deviation is 2.96. Go back and check the range. The range is 9. And for the variance, it's located under stack, basis statistics, and then variance. So the samples are in a column. The column C1, and click OK. And give you the variance of 8.79. If you want to do it by hand, it tells you that you first need to calculate each value minus the mean. Then you have to square that difference. Then you have to add up all these results, the sum of them. Then you have to divide them by n, and then that will give you the variance. And then to get the standard deviation, you will have to get the square root of that value. It tells you how to solve it. So you first get the range, you got the mean, and then you get to work each step by step to get the variance and the standard deviation. The numbers vary here with respect to Excel and Minitab, and this is because the number of decimals that we use by hand, or the calculator, or the Excel and Minitab use it. This is all for measures of dispersion and other type of measures.